Good morning, students. How are you all? I hope that all of you are fine. And once again, we are going to learn about light. And already we learned some few things about the light. And in last class, I teach you about laws of reflection. Two laws of reflection. The first law it is angle I is equal to angle R. The second law it is incident ray, reflected ray, and normal drawn to the interface will lies in the same plane. These are the things. And next one we are going to learn about image formed by a plane mirror. Image formed by a plane mirror. And plane mirror in the sense, here every day we will see our face in a mirror, that is dressing table, or whatever we are using in the salons, hair cutting salons or beauty parlors, and these are all plane mirrors. Plane mirrors, this is what we are seeing every day, our face, that is a plane mirror. So in that plane mirror, we are able to see our image. So what is the properties of that image, what is the characteristics of that image? This is what we are going to see here. It is okay. And before going to that, let me teach you about two images. One is a real image, and second thing is that virtual image. Which image is called real image and which image is called as the virtual image? Okay. And if light rays are really passing through this one, if the first point it is, if light rays are passing through the image really, and that is called here a real image. And suppose if these light rays are not passing through that image, and that is called here virtual image. Okay. And in a simplified version, in a simple way also, I will teach you. And which image is called real image? Suppose if you keep a screen, and if you are able to catch your image on the screen, and that is called here real image. If you are unable to catch the image on your screen, that is called here virtual image. And so here it is. Suppose if you keep a screen is nothing but a paper or anything, you can take it, and the paper is a screen. And if you keep a paper beyond our plane mirror, can you able to see the image on the paper behind the mirror? No, we are unable to see. Why? Because of the rays are not passing through that paper. So that is called here virtual image. If we are able to catch the image on a screen, and that is called here a real image. Okay, I'll give example for real image also. Suppose if you take a magnifying lens, magnifying lens, this is at the childhood we may played, and suppose if you take this magnifying lens, and if you keep under the sun rays, and sun rays are coming from long distance, and this is the magnifying lens, and below that you can find out a dot. This dot is the image of the sun. This dot is the image of the sun. And for this much of the sun, large sun, and that is having a radius is many kilometers, and we are taking the image. It will be a point size, small size of the image on the paper. Suppose if you keep here paper, you find out a dot, and this dot is formed because of the light rays passing through, and we are able to catch the image on the paper. Here it is on the screen. So that is a real image, and this is the virtual image. So here we can say that the first property, the first characteristic what we are seeing in the plane mirror, that is a virtual image. Virtual image. And second thing is that whether the image is larger than the object or smaller than the object or same size of the object. Suppose if you are standing in front of a mirror and the size of you and will be equal to the size of the image inside. Suppose if you are having 1.5 meter or 2 meter height, 2 meter length, the total length from head to toes, it is like 2 meter, and if you measure the image inside the mirror also, and that will be 2 meters only. So here the size of the object will be equal to size of the image. The same size will be there. Suppose if you have taken this much of small size object, small size ball, it won't be appear in a big size ball or very small size ball. Okay, and if you have taken this much of size ball, and the image is also the same size will be there. So there is no change in the size of the object and size of the image. And the third thing is that, and suppose if you are standing in front of the mirror, suppose 2 meters, and behind that mirror the image is also the same 2 meters will be there. And suppose if you are walking towards the mirror, and the image will also move towards the mirror. Suppose if you are moving away from the mirror, and the image also moves away from the mirror. Suppose the distance between you and the mirror, it is 10 meters, and the distance from the mirror to the image is also the same, 10 meters will be there. So here it is distance of the object to mirror is equal to distance of the image from mirror. And this is a third point. And fourth point, it is the laterally inverted. Here what do you mean by the word laterally inverted? Laterally inverted in the sense, suppose a object, suppose you are the object and you are standing in front of a plane mirror, and your right hand will be seems as the left hand, okay, and your left eye, it seems to be right eye, and your left leg will seems to be right leg only. Only left and right will be changes, interchanges. That is called here laterally inverted. And generally we can talk about inverted image, completely inverted image. Completely inverted in the sense upside down will be there. That means our head will comes down and legs will go up. Imagine your situation if it is that was the case. Okay, and that is not completely inverted. This is laterally inverted. And here up will be up and down will be down, and up the top side of the object will seems as the top side of the image only. And that type of image, it is called here erect image. And suppose your image will be suppose you are like this, and your image is like legs will be up and head will be down, and that is called inverted. So here these 4 points are important, and they may ask for 1 mark questions also. And here virtual size and virtual image, and size of the object will be equal to size of the image. So distance of the object distance is equal to image distance. The fourth point, it is virtually this is laterally inverted one, and we can say that this is a erect image. Why? Because of upside will be upside only, downside will be downside only. So here, suppose let me draw a simple figure for this one. This is the plane mirror, and back side it is coated. And always when I am showing these lines, in the figures, and you think that you treat this as the coated one, and here it is coated, and if you are standing here it is, and here is a person is standing, and this distance is 10 meters, and here also, and here some image is formed. Since it is coated, here it is, all the light is reflected back, no light will be goes into this one, no lights should passing through this image. So that is why this is called here virtual image, and this is also same 10 meters, and if this height is like 2 meters, and this height is also like 2 meters only, and whatever the height, the orientation it is, and this is also same orientation. Okay, it's not like upside down. Okay, the head will not be here and legs will not go, and this is called simply, this is virtual. So in future also, when we are describing about the image, there will be three things will be there. The first thing is whether it is a real image or a virtual image, you have to say the first thing, and second thing we have to say about size of the image is smaller or larger or equal to the size of the object. Here it is same size as object. And the third one, it is whether it is erect or inverted. These three things, these three qualities are very, very important. So this is the object, this is the image, these are the characteristics of the image. In future also, I mean, not in the case of plane mirror, but in the case of spherical mirrors also, you have to be follow like this only. So this is all about image formed by a plane mirror. Next one, we are going to learn about spherical mirrors. And for this I'll give a simple example. And in our houses now also, in this quarantine time, you are in house, so you take a spoon. Okay, the spoon will be like this, the spoon will be like this, the spoon, and in this one you can find out spherical mirrors. Okay, and this is a inside surface, this is called here concave, and this outside surface, this is called here convex. There will be two types of spherical mirrors will be there. One is a concave mirror and another one is the convex mirror. Just I'll give a little bit of introduction about this one and I'll leave you. This is concave mirror. Here it is. If any mirror, if you take like this, this is the shape here, and back side it is coated. How to define this concave mirror? The reflecting surface is inside the curve, and it is towards the center of curvature. The reflecting surface, this is the reflecting surface, this is inside, this is the reflecting surface. Here it is. That means when light falls onto this one, and the light will be reflected back only, and this reflecting surface is inside, and not only that, and it is towards the center of curvature. Center of curvature, here I am repeating this one, center of this center of curvature is a very very important concept. What do you mean by center of curvature? By using this curved surface, if you are able to form a sphere, not a circle, and you think three-dimensionally, and suppose if you form a an apple shape, or a football shape, or a volleyball shape, whatever it is, and this is a sphere, and this sphere center is a center of curvature, and this reflecting surface is towards the center of curvature. See, such type of mirror is called here concave mirror. So here, what do you, second thing is that convex mirror. Convex mirror, sorry, not this one. And inside it is coated. Now inside it is coated, that means here the object will be here, and some light will go and will incident on this one, and it will be reflected back. So here, how to define this convex mirror? The reflecting surface is outside the curve. This is a reflecting surface, this is outside the curve. Reflecting surface is outside the curve. That is called here convex mirror. So this is the basics of the spherical mirror, and the next class I'll teach you more about this one, and I am unable to upload the large amount of data, so that's why I am stopping now here, and I will make another video very frequently, and I will upload it. Thank you.